Okay, so yesterday we found a bug where when we would drop our mouse stones in a new grid, they wouldn't adaptively resize. So look, if I drop these two in there, see that border? That border is there when they should adaptively resize depending on the occupant that is in there. So now if we take a look at this, in our drop stone logic, we're assigning the stack order here. Okay, so if you take a look at what we're actually doing, let's take a look at what we're actually doing in our function. We're saying that the stack order gets assigned to be the lowest mouse stone stack order. And we copy over the original stack order as well. Now the original stack order is useful for picking it back up because I'm just trying to find this bug because I think it's just right to do when we drop our stone. So come on here. Shoot. I don't know. Here we have, if we press down to drop a stone, the stack order of the grid we're dropping it in, the stack order gets assigned based on the occupant index. Now it gets assigned on the occupant index before we decrement it. Shoot. I don't even see where we're... Let me take a look at this one. Yeah, same deal. We take the occupant index, and that becomes the stack order of our member at that index. But see, we're not... Okay. So we don't really increment this occupant index. We only really assign this upon being dropped. So if we're dropping a stone, we assign our occupant index to be equal to the amount of occupants currently in that grid. But we actually we increment it right up here. So we increment it, then we assign it into our variable called occupant index. So this should hold the index of 1 above how many occupants are in that space. So now if there's no occupants in that space, there'd be 0. Then we increment our occupants to be equal to 1, therefore occupant index is 1, therefore the stone we're placing from our mouse stones is going into index 1 right here at this occupant index. So if we take a look at our drop stone function, we do something very similar. We increase our occupants. We then set our occupant index to be equal to that occupant index. Now here's where the mistake is. Instead of copying over the same exact stack order from our milestone members, what we're trying to put here is our occupant index, because we're saying whatever this occupant index is going to be the index of the next stone in the grid. So we're saying when we put a new stone, its stack order is going to be that occupant index, which is one higher than before we dropped a stone. So we drop a stone, then it would increase this, and then that's where we'd put the stack order. So changing this to occupant index should fix our render problem. Let's see. So we drop a stone, we lock in a move. Now see there's a grid around it. If we drop a stone, it should adaptively resize to be the full screen, and it does. So see how it kind of, it is not getting back on our original stack order though. So we need to fix that, which is in our pickup stone. We need to assign our stack order to be our old stack order. So our stack order is going to get the original stack order. And then we're going to copy over the original stack order, add that index into the mouse stone's original stack order. That might work. Let's see. Okay, so look, we drop it, it adaptively sizes, and then when we pick it up, it shrinks again, which is good. So that's looking right. So we at least fixed that bug. It's just that now we need to detect whether or not our second movement grid is at the edge of the grid, which we used this variable called offGrid to detect. And we detect that in our movement 4, and we detect that based on our next move direction. So I'm thinking we need to make this into a function, because we're not ever flushing this off grid. Well, I guess if off grid is true, we know we have to make the player dump all their pieces. So as long as we flush off grid upon a player swap, we should be okay. Let's see if we do that. Well, we do it upon a reset, and we should do it upon, yep, we do it upon a player swap. So let's find this again. Let's see where this is. So now we're using this variable called next move row to determine whether or not we're off grid. Now, we're doing that all right here. We're saying if our up is locked in, our next move row would become our first movement row -1. Okay, this is going to be a little hard to do a function for, but I think it's necessary. Because for all of the movements, first movement through second, third, and fourth movement, if any of those grids are in a spot where the next move would be off grid, which we're doing for this, then we need to toggle this variable called off grid to be true so that we can enforce the player to drop all of their stones if their next move would be off grid. So we kind of need to turn this we need to turn all of this into a function. And that function needs to take in the current spot we're at, which is our first movement in our movement event 4 at least, because we lock in our first movement. So we would be running it on the first movement here. And then look where we use it. We say, if enter is pressed and we're off grid, then we would only swap our players if our occupants are 0. And then not off grid. Okay. So it's almost like as soon as we lock in our next direction, our next movement row, we can run the function passing in our next direction to give us our next off grid for our next space. So this is going to be a little tricky, but I think we can totally do this. So what these two blocks are doing is, depending on the direction that's locked in, it's assigning our next move to be, it's basically just assigning into these variables called next move row, next move column, and it's assigning whatever the next grid would be based on our locked in directions. So then the next thing it's doing is saying, hey, if that next move is off the grid, we're off grid. It's as simple as what it's doing. So it's basically saying, look, if our first movement column was 1-1, meaning we moved left or up into this first movement column, then its next move row would be less than 1, meaning off grid. Or the column would be smaller than 1, meaning it's off grid going to the left. If that's the case, we need to make sure we drop all the stones. We need to have 0 occupants in our mouse stone in order to swap the player if we're off grid. So yeah, so this would need, if we turn this into a function, look, let's say that this is going to become a function, and that function is called something like next move off grid function or something like that, because it locks in your next move based on your direction and your first movement, which we need to scale, so we need to allow it to be a parameter so that we can pass in a second movement, so it can calculate the next move row and next move column for a second movement based on the direction. And then it actually toggles the off grid, so it does two things. So I guess, do we swap this into 2 variables? Do we have a next move set function that overrides these global variables with the correct next move, and then we use that next move in our second function to determine whether or not we're off grid or not? Or do we just do it all in one? I kind of feel like this should just be called next move off grid, something like that. And then we can do both, because it's like, we'll be passing in the first movement row, first movement column, at least upon this movement event 4, and then it should toggle this off grid based on the next move row that it gets from that locked in direction. So I think it's okay for this to be one function, but let's see what that might look like in practice by going to our functions And in our pickup, after our pickup stone function, we're going to give ourselves a new function. And that function is called what? It's called next move off grid. Okay. And it takes in a current grid row, current grid column. Okay. Now if we paste in our old code, we can build this out again with our parameters, and we can say, hey, if the next move row is equal to nil, then we would assign our direction. No. What this is basically doing is saying, I don't think I like this, is equal to nil. Because the whole idea was that next move row starts off as nil, and then if a direction is locked, it'll get populated, and then it'll no longer be nil, therefore we don't keep overriding these values. So let me just see where. See, because this logic is not under a button press, so it would just run 60 times a second. Now, once you click in a legal move, when you have stones in your hand, which is this movement 3, to select the first movement grid, we should probably do it here. Because as soon as we click on that space, as soon as these directions are locked in, we know, we theoretically, know what the next move row and column is. And if we know what the next move row and column is, because this should only happen once. It's only if since we're moving the movement event upon a click in a movement event 3, this should only ever run once. So I think our function should go here. We should run our, what did we call it? Next move off grid function. We should pass in, remember we called it current grid row, current grid column. So our current grid at this point would be our first movement. We're doing row first, column second. So now if we have this function called once here upon that press, it'll populate our next move index, or next move row and column, and it would populate whether or not the next grid is off screen or not. So see, and this is a little confusing because the next move off grid, if we pass in our first movement row, it would be checking if our second movement row would be off grid, no. So maybe we say, okay, holy crap. Oh my God. Here we go. I'm confused if we name this current grid row, if that makes sense for what it's actually doing. In a movement event 3, when we click on a legal move, we lock in our first movement. Therefore, our current grid row and current grid column would be that first movement. Then it would be determining what the next move row is based on the direction and the updated first movement. Okay, I think this can work. Wait, I don't want to do this nil stuff because we're not running this willy-nilly in the update function anymore. We do it upon a click detect. So that should fix that. And we can say, you know, if up direction, do all the, here, we can do okay. Now, we don't want this to be first movement row, we want it to be current grid row and current grid column. Same with all of these. So this way we don't have to put this code every time we're trying to check whether or not our next movement would be off grid, which would be every movement from first movement on to the fourth movement. Current grid row. There we go. And I'm just going to make row the first one in each because it's just easier for me to think about it like that. Row, then column. Okay. So far our next move off grid function takes in 2 arguments. A current grid row and column. Current row and column of where our move is, and then we assign what would be our next move row and column, and then we do checking and say then we can say all of this good stuff, which is if our next move row based on whatever our current grid row is would be off grid, then we're off grid. Okay, now I'm going to get rid of this. Okay. Yeah, we can't just put them all in an else if because it would actually mess the logic up. So now the question is, does this work as expected? With our next move off grid and passing in a row and a column, it should set our off grid variable to be correct. So actually, let's see where we first use this off grid. Probably movement 2. movement event 3. Yeah, when we select our first movement, that's the first time we should be able to know, because that's when we lock in our direction, which we're doing right here. We lock in our direction. Once our direction is locked in, we can run our next move off grid function, which takes in a current row and current column because we just assigned our first movement row and column, so we can pass those in, at which point will be a movement event 4. Now this is where all that code used to be, which I'm gonna just delete, or I don't know. I'll leave it here for now in case we break something, we want to be able to turn it back on. So using this function should populate our off-grid variable with true if we would be off-grid and false if we're not. So at this point, when we get to the enter logic, this variable hopefully is still readable and correct. So let's test this for our movement event 4, and we'll see. So if we're testing to see if our movement event 4, that's our first movement row. So we're trying to see if our first movement row's next grid would be locked, and we can do that with the current setup we have. Because if we lock in a direction over here, our next grid should be locked, and if our next grid is locked, we can't advance to movement event 5 by pressing enter. And I'm pressing enter and it's not. Yet when we drop all of the occupants, then press enter, it'll switch. So it's looking like this code we took out and now put in our function here is working correctly. It's looking like that. I can't say for a fact, but look at how useful functions are, because all of this blue, all of this blue, all of this blue are taken care of with these two functions, drop stone, pick up stone. And then all of this is taken care of with this one line, next move off grid. Granted, we do have a copy of that code higher up, but we're able to reuse it because we have to reuse it for our second movement, third movement, fourth movement. So let's go ahead and try to do this next move off grid. So once we lock it in, yeah, check this out. Once we lock in our new row and column for our direction, then this is locking in our new, and keep in mind this part of the loop is saying, hey, we've dropped at least one in our first movement and we're not going to be off grid on the next move. Therefore, if you press enter, which is up here, press enter, at that point we'll shift to movement event 5. Now we need to run our function here before this, so we need to pass in our second movement row, second movement column, and what that'll do is ensure that by the time we add our enter logic here for this movement event 5, which is the last bit of logic we need for this movement event, we'll be able to use our if off grid. So let's go ahead and add that. And then once that's all done, we'll get rid of a bunch of old code so we can navigate this better, because it's getting silly to look at. So in our movement event 3, that's when we get our first movement direction locked, and that's when we're running our first next move off grid. Now we don't use the off grid variable until the next movement event, and we do that upon the enter being pressed. So I'm going to copy this over as a sort of template because this is what we need in a movement event 5 as well. And anytime we copy like this, we got to keep in mind, how can we not have to copy? How can we use this? How can we write this in a smarter way? For now, I'm just trying to get it to work, and then we can worry about doing it right. So we're going to say here, this is where all of our code goes. And if enter was pressed, some computers have it enter, some have it return. Then if we're off grid, we only swap our players if shoot, man. Okay, never mind. I was just getting overwhelmed, but we should be okay. So what this is saying if we are off grid, enter is pressed, and we're off grid, and our occupants are 0, that's when we would need to swap players. But before we swap players, we need to update our stone control for our grid that is currently active, so our second movement row and our second movement column. We update stack control for our appropriate row, and then we turn our current row, which would this mean third? No. This is turning our current space that we're selected into being occupied. That makes sense, I guess. Because we don't, until we press enter, we don't lock in how many stones are in the current spot. And if we had dropped any amount of stones in a grid, we know that grid is now occupied. So then what we're doing is we're saying if the stone we're saying explicitly here, if our movement origin stone has no occupants, then we clear control. Now, I don't think we need to do this. Well, we also clear control of the movement origin row if our occupants are 0 and we're not off the grid. We also clear it if our occupants are 0. So this would be enter pressed with dropping all stones. This would be enter pressed while this is enter pressed with dropping all stones. This is off-grid ending turn. This is enter pressed while dropping all stones. And then this one is enter pressed after dropping some stones, not all stones. Okay. Now, in every one of these scenarios, we're clearing control of our movement origin. So why don't we just say, yeah, we do the same line of code. If our occupants are 0, clear movement. I don't exactly know. Sorry, this is a confusing one, guys. I'm confused too. I'm trying to decide whether or not we need this everywhere. Enter's pressed. We're clearing control in every scenario. The only scenario we're not doing it in is if there's some occupants in our movement origin still. So I don't know how to do this better. I don't want to move this out of these 3 blocks, even though it's like the same code for each time, meaning it's like the same block. But if we just do it up here, we'll do it regardless if we're off grid or not, or regardless of how many occupants are in our movement origin. So we need to make sure we don't do that. We only clear control if there is 0 occupants in our movement origin. Now, I don't think we actually need this, because upon a first move, since this is a movement event 5, upon our movement event 3, we would have cleared this already. Because this is to determine how many stones, or if we move all of our stones out of our movement origin, that we flush our stack control and stone control. So I actually don't think we need this anymore. We only need it for that first one. Which we're already doing. So now we're going to make sure we have the right index here. Second movement row. So we need second movement row. And then I don't think we need this either. Because we should be flushing this already if there's no occupants. So we shouldn't need this either. Okay. And then we just need to update stone control for our correct movement here. Sneaky one over here I almost missed. Now, we're also going to be locking in our third movement at this point. So we do that based on whatever our current movement was with some arithmetic here. So we need to replace the right side of these equations with second movement instead of first, because we're trying to update our next move. So we have to give it our previous move, which at this instance is now second. Okay. Okay. Then we run our next move off grid given our new second movement row. So what we just added should allow us to do is to hit enter with any possibility of actually, like, yeah, let's test if our second movement would be the end. So if we move our grid from our 1-4 over to 1-3, our tester grid, here we need to move our option command F, and we find all of our 1-4s. Oopsie, not that one though. Yeah, we're trying to just go 1-3. Now if we move to the right with a 1-3, our second movement should turn out to be off grid. Therefore, if we press enter with stones left, it won't work. But if we move down, we should be able to continue. So let's see if that is the case. We switched our tester to be left 1. Now we can test our second movement locked. And we can say drop 1 here. Now, by the time we drop 1 here, I'm hoping this second move off grid would be true, which it says true. So let's try to hit enter, and hopefully it doesn't do anything. Okay. Now, if we drop in all our stones, then hit enter, it swaps players. That's looking right. Then if we reset, now try the same thing, just not end on a off grid, which if we take a look here, our off grid is false. Now we should be able to just drop 1 and then hit enter, and we should actually go to a movement event 6 at that point, but we didn't actually do it in our code. So yeah, this should be movement event 6. Okay. Let me just see if that breaks anything. It shouldn't break anything. Okay. Yeah, we locked in our third movement at this point, which we need to give ourselves, we need to initialize this. Third movement locked. Third movement row gets nil. Third movement column gets nil. And then our reset, We don't have first move. Oh no, we have them separated. Okay. So now we shouldn't be rendering our next stone just yet, but I'm hoping it'll say movement at 6 and then, yeah, I'm hoping it'll just say movement at 6 and allow us to actually lock that in. So if we hit enter here, it should be movement event 6, which it is. And our stack control is looking like it's correct. So that's good. Cool. Okay. So we are upon this oh my god. Here we go. We're locking in our third movement based on our second movement and our locked in direction, which is correct. We're testing whether or not the next movement would be off grid, and this is going to be handy in movement event 6 to determine if we're off grid on a fourth move or if we can actually move 5. So that's going to be coming in handy next, but I think that's all for movement event 5. Yeah, I think that's it for movement event 5. I am sick of looking at all of these commented out junks. So I'm gonna just delete them all. Should we commit before we clean up? Or just trust that it's all old nasty stuff? Well, let's see. This is our dropping stone logic, which we have in our drop stone class. I don't think we need this anymore. We shouldn't need this pickup stone logic in our pickup function. I think we're good to delete everything that's massively commented out except for our tester stacks, because this is just all of our old drop stone logic, all our old pickup stone logic. Same thing with here. Oh, we got this in a function now. This is our old drop off, our old pickup. We should be able to massively consolidate this. Okay. So, yeah, we should be good. Now, I think I'm at the point where I don't even want my old code anymore. Because I think where we're at right now is actually right where we were stuck. We were stuck testing whether or not we were at the end of a grid on a second movement lock, if I remember correctly. And we seem to have figured that out. So I think we can just get rid of all this. Yeah. Now I'm gonna make sure we gotta be doing this. Some sort of this falsifying legal moves again, right? Yes. Well. Let me see. Yeah, we moved it into a function, called falsify occupant's legal move. Okay. Oh, we have it right here. Okay. We have it in movement event 3 for some reason. Oh, I guess that makes sense because movement event 3 is when you're selecting your first movement grid, so we just need to make sure we don't accidentally highlight a capstone or a standing stone, so that makes sense. Okay, I think we're good to get rid of all of our junk code. Now if we 1,500 lines of code we're at right now. We're going to see how much this consolidates, because look at all this blue over here. So we're at 1,500 right now. We can honestly get rid of our old debug stuff. Guess let's start at the top. We know we need our stack tester still. Now we can get rid of this. And then we can collapse this. We can get rid of this. Collapse this. We can collapse this. Okay. Now we're in our update function, which we can go ahead and collapse this. Collapse this. Collapse this. Collapse this. Collapse this. Collapse this. Okay. So this is mouse press detection for a move type place, which is fine. For a move type move, we populate all our mouse stone members. This is updating our X position actually based on our mouse every single frame if we're in a move type move. So this is, now we're in the good stuff. Movement event 1. Cool. So yeah, now we can kind of visualize this. Why can't I collapse this? Okay. Movement event 2. We can get rid of all our old dropstone logic. We're just running that one function now, which is really nice. Same with our pickup. Nice. Look at that. This whole movement event is now condensed to this many lines. We just run the dropstone function, run the pickup stone function, update stack control if we're pressed. If enter is pressed. So that's cool. Now, what is this one actually doing? This is drop stones in movement origin. Okay. Nice. We should be able to kind of get rid of all this. Now, this is actually selecting the first movement grid. So like, yeah, locks in our first movement grid based on where we click, as long as it's a legal move, right? Yeah, as long as it's a legal move. Locking in that direction. Changing our movement event. Okay, cool. Nice, nice, nice. Movement event 3. Movement event 4. And what's the difference? Why can I collapse this one and not the other one? Ooh. Hold on. think this one is screwing us up. And we can put this here. Get rid of this. Okay. Now we should be able to start collapsing these. Okay. Looking much cleaner. Once we clear up 4. Yeah, look at how much cleaned up 4 is looking already. Nice. Okay. Yeah, so off-grid ending turn. Then we have enter pressed after dropping all stones. Not off-grid. Occupants 0. And then the last one, enter pressed after dropping some stones. Okay, I noticed one thing that we've got wrong, and it's that this one is fine for dropped in first movement, because when we drop, we're actually dropping the first movement, but here, oh, no, we have it right, dropped in the second movement. Yeah, we have it right, okay. Cool, so movement of 5, movement of 4 is done. Then what we just did today. And we can actually do this for the beginning of our movement event 6 to kind of kick us off, which is to render the grid at our next space to be true upon a movement 6. So we'll do that. Nice. Okay, so if a movement is 6, then we're going to say our third movement row that we just locked in is going to get dark green. That's what this move locked highlight will do. So now, oh my god, yeah, once we delete all our old code. Look at that. Oh my god, yuck. Okay, deleted all that. We went from 1,500 lines to 950, so we got rid of 550 lines today of old code and notes. So now, if we get our movement events squashed down, now we can see that, you know, here's our testers. We can minimize our testers so they're not so huge, minimize our functions so they're not so huge. And then I can show you how much easier it is to look at the game now. So here's, actually I don't want to do that. Okay, so these are our functions. Our testers, our reset, this is also a function. Then our update function, here's a bunch, and then here's our move type move for all these events. So it's just so much easier to look at now. Yep, much easier to look at now. Cool. So now we don't have to dive around this huge 1500 line code mess. We can just look at what movement event are we in? 6. Okay, let me go, you know, or 5. Let's expand that, check it out. So now we don't have to break our eyes looking at our own code. So the only thing we've done in movement event 6 so far is to highlight the third movement row. So let's see if that's working. So let's lock into downwards. Now once I hit enter, it should allow us, because we have a stone and it's not off grid, which we can see that we're not, that off grid is false. So if we hit enter, I'm hoping the green highlight will show up, which it does. Nice. So that was our movement event 5 update. I think we're done with that, but we could have missed something. I'll have to do some testing, but that's a pretty good chunk for today to kind of polish up. I'm pretty sure we're caught up now. We're actually, with this line of code, we're actually a little ahead of where we were before we deleted all that old code and refactored it so that we can actually just handle it in all these movement events like this, which is a way better idea. So our git diff here is going to look ridiculous. I'm not going to go through it all because it's going to look disgusting. But we added a third movement row and column, different testers. We reset our third movement row and column in our reset and player swap function. We add a new function entirely, next move off grid, where we move all of our next move variables, which is what our next move row is and whether or not that next move is off grid or not, into a function. We took out all our old code. Is there a way to speed this up? It's just really going to take forever. So look, we deleted 500 lines of old code. Some replaced with functions, some replaced with better logic. This was rehauled completely. Wow, that's a huge update. I mean, this was all commented out, so it's not like I really changed that many lines. I just decided I didn't want it anymore for reference. Wow, okay. And yeah, that's it. So git add everything with a commit message saying we completed movement event 5 logic. I think we did it. I'll say still needs thorough testing. Look at that, 99 insertions, 602 deletions. Not a bad commit there. Okay. I will see you guys tomorrow. I'm watching a friend watching their house this weekend. I'm gonna try to. I might be doing some episodes on my laptop for the next 3 days. Or I might come back here and try to squeeze it out, but probably just do it on my laptop. So I might be figuring out a different setup for my laptop. Maybe I'll, it'll be the first episode streaming from my laptop, I think. So there's that. I'm trying not to miss any days in March. So we'll see if that continues. Are we halfway through? Yeah, I'm gonna try to make it through March without missing a day, which would be cool. And then I will see you guys tomorrow, and we'll get more work done. We're in the home stretch. We got up to 4 moves with adaptive stack scaling and off-grid locking, whatever you want to call it. So we're making some really good progress. If I had to guess, I'd say we're like 80% done with everything. Maybe a bit more, because we've already got all the functions for our movement event 6 and 7. We just need to implement them, and then at that point, if those are working correctly, then all we have to do is worry about wind state. So we're doing really good. I will catch you guys tomorrow.